Good morning, everybody. Okay, let's try that again. Good morning, everybody. Okay, great. Some energy there. Thank you. So my name is Marcel de Vries, and welcome here to the session from 1 release per quarter to 30 times a day. I'm so thrilled that you're here and you want to take this journey along with me to see how we can release multiple times a day. So first, let me start with a question to all of you. So why 30? Why did you guys come to a session and you really want to deliver 30 times a day? Anybody, any idea why I chose the number 30? Because as geeks, normally you choose another number, right? 42 or something like that. I mean, that's who we are. That resonates more with what we do. The reason I chose 30 and not once every week or once every 2 weeks or shave off a little bit of speed there, it has to do with I want to unlock a new, different type of thinking. And it has to do with the fact that we are ingrained with the things that we do for so long that we sometimes forget that there are other ways to achieve the same goal. And if you want to release 30 times a day, all of a sudden, certain things that you're used to do are not applicable anymore. And that's the reason why 30 times a day as a goal will help you rethink the things that you're doing today to get you towards your final goal. Another question I have for you is duplicate code. Do you think that's bad or good? So who thinks that duplicate code is a bad thing? Anybody? Okay, good. I see a couple of people waving a little bit. I think that means it depends. And the thing is that, and this is where I want to start at, is if you're talking about duplicate code, we are often not aware of the fact that we're trading off certain principles. We're trading off two things. We have learned from 101 in computer science that, well, when you duplicate code, people give you a slip on the wrist because you shouldn't do it, and it's a bad thing. But why is it a bad thing? Well, in the past, it was a bad thing because it was very hard to find all the duplicates everywhere and then make changes to those duplicates if there was a bug or if I needed to change my business logic. So that was the reason we have been taught that duplicating code is a bad thing. But nowadays, look at your code repository and just do a search on a certain piece of code. You will find all the clones in there within milliseconds even. So why is it still bad? In that respect, if I can very easily apply a change in that code in different places, because the trade-off that I've been making is the fact that it's hard to change that code over my whole code base, is that I now create a central thing which I create a coupling on. Now the funny thing is, as developers, what is the thing that we're constantly striving for not to create? Coupling. So we're trading off duplicate code. We prefer to couple instead of having it dispersed over our code base. Now, the thing that I'm trying to convey here is that you constantly need to ask yourself, why am I doing this? What is the trade-off that's in here? And why did I learn to do it in a certain way? Because only if we ask ourselves the question, how can I do it differently, or why was I doing that again, and do these constraints still apply, that's the moment I can unlock a second level of thinking, a new plateau of enlightenment, you might say, in which you then say, oh, let me do it a completely different way, and now we're achieving much more than just shaving off a couple of hours or a couple of days in our release cycle. I mean, ask yourself the question, how long does it take to get a new server these days? Not that long anymore, right? It's just, if you're using the cloud, just a couple of minutes, and you have a new server. But the thing is, our processes in our companies are completely ingrained in the fact that it was hard to get a server. It was a capital expense that we needed to make. We needed to get approval from our managers. Then we needed to fill out a form what kind of spec we wanted so that procurement could buy a bunch of them so it would be cheaper. And that's the way our organizations have been organized. But nowadays, with instantaneously compute when I need it, those constraints do not apply anymore, and there are different things then to look at how we can release our software and test our software. How much do I need to invest to, for example, get into a new market? Well, in the past, we needed a lot of money to buy servers, buy parts of a data center, get all the software written, etc., etc. But nowadays, we see all kinds of different startups, different companies disrupting old companies because of this fact. Because of the fact that they do not need a lot of capital investment before they can get started. It's just somebody at the attic that writes some cool code, gets some tweets out, and all of a sudden people pick it up, and there you go, you got a business all of a sudden. And the only thing you needed to do is swipe a credit card and pay as you go. And it's interesting to see that the constraints that we had in the past for starting a taxi company, I needed to buy taxi cars. Well, Uber did it a different way, right? Everybody has a car, just share your ride, and all of a sudden we have a taxi company that does not own cars anymore. If you look at Airbnb, everybody has a house, why not rent you a house? And all of a sudden I am a hotel chain without owning any real estate. When I'm creating content and I want to publish content, I let people create their own content and I own it still because I'm Facebook. It's a complete different model. Which disrupts our markets, but it's also, for me at least, a point that I say, okay, I need to rethink the things that I've been doing for all those years. So what you see is that over the past decades, organizations have been focused on what we call operational excellence. And operational excellence is all about how can we optimize around a set of resources. By the way, if you talk about resources, I prefer to talk about people, but managers and people always talk about resources, but I like to make it more personal though. The thing is, what we see is that in our brains, we've been taught from kindergarten on, is that certain things belong together. And the way we are used to group these things together is what we call logical cohesive. They're logically grouped together. So it's all the figures that are round go with the rounds, and everything that's a star go with the stars. Well, we learn in kindergarten, right? That's the way we learn to group things. And this is ingrained in our lizard brain, which has to do with our perception of things. Now, the thing is that if you look at how we should optimize our organizations and how we want to address new markets, is that we need to step up the pace instead of optimizing on these resources. Because what is the one thing we do not have enough of? Time, exactly. That is our problem. Time is crucial, but if this is the case, why are all our organizations optimized around the resources instead of time to market? Why does it take like weeks to go from development to test to acceptance to production? And we have different incentives on the production side, make stuff stable and do not accept any changes, while developers on the other hand, make as much new code as you can and check it in as fast as you can. But we will keep you there before you can actually go to production, right? So we're completely optimized in the wrong way. So we need to move away from resource optimization to time to market optimization. And that's a very important part of the organizational side of things in order to release faster. Now what I would like to do is I would like to do a little social experiment, and I hope you will bear with me. So this is one of those sessions that you participate. I did not announce that because otherwise the room would be empty, I think. So I would like to ask everybody to stand up, please. For those that don't, that also gives me some information. This is very cool. Which is part of the social experiment, by the way. So what I would like to do is I would like to create a baseline. As a consultant, I do a lot of baselining and then see how I can optimize things. So what I would like to do is I would like to make as much noise as we can in this room by clapping our hands, okay? So on the count of 3, we will clap our hands. That gives me a kind of an indication what sound level we can create based on clapping our hands, okay? Everybody with me? Okay, on the count of 3. So 1, 2, 3. Thank you so much. Please sit down. This is for me a nice baseline, and of course also a nice applause while not doing anything yet. But this gives me an indication, okay, where can we go if we would like to optimize this in the future? Now, if you look at this change that we're trying to achieve in organizations is optimize around time to market versus resource optimization, that's where we meet DevOps. And DevOps is then the union of people and process and technology to enable continuous delivery of value to our end users. And it means that we need to deliver it as fast as possible, and that's what we're trying to achieve. So how would a journey towards multiple releases look like if you want to become a DevOps team? And let us take a journey here where we have this company called Music Store Incorporated, which sells vinyl records on the market. And they have an online shop, but they need to compete now in the market. And they face all these kind of issues. They have these issues that they are now running in their data center, and they need to do a new capital investment on their hardware. It's very hard to make changes to the current application. It's a little bit of a monolith, and how do we create new changes without giving away our weekends all the time, so that we all know probably those weekends that we all need to come in with a whole big team, and then we all start playing cards because it's one other person, it's turn eventually to do something, and then we go home at the end of the weekend and we did a new release. Every release that we do requires downtime in this situation, which is something that in a 24/7 economy does not really work anymore. It's hard to compete in their business. They need to sell different products eventually, so they want to become an Amazon or something like that. And they need to revamp their whole online platform for that. So, welcome Music Store Incorporate. You probably have seen Music Store Incorporate in the past. This is just an old MVC3 application. I told you it would be a legacy application that we're moving towards the new era of releasing multiple times a day. And this Music Store is what we're going to move forward with the current state of technology and the current way of new thinking regarding constraints. So the idea is that Music Store Incorporate will start off with doing things different. They are going to create a more custom-centric approach. They're going to look at what we call value streams. That's the way you deliver the value to certain parts of the customer. This is, by the way, where we already need to look at our application from a different perspective. We need to look at it from what we call functional cohesion instead of logical cohesion. What you see is that we have something like UI, we have something like business logic, we have something like a data layer. Well, that is logical cohesive, but what we need to do is, what is that we deliver in terms of value? So the whole customer journey, you might say, of getting on your website, clicking through a certain set of products, doing the shopping basket, and then checking out. That would be a journey which you then can compose out of different components. They are going to move to the cloud, because the cloud tipping point, by the way, has been there in 2014, right? So all the companies are moving to the cloud. I'm not sure where you guys are at. If you're in a submarine, then probably it's harder, but otherwise, when you have some connectivity, then the cloud makes a lot of sense, and especially for this type of a business, which is nothing more than an online retailer. So they are going to change all these things in their environment and see how they can align it to be successful. Now, from an organizational perspective, what they need to do is they need to create flow. So the flow is about how do I deliver something and move it to production as fast as possible with getting rid of all those boundaries that we had. And there is a theory of constraints that you can apply to optimizing how you want to deliver to production. And this is some of the things that I use a lot when I do consulting gigs, is I come into a company and what I do is a value stream analysis. And a value stream analysis is how long does it take to get from A to B? What are the steps in the middle there? What is value add and what is non-value add? And what is, of course, repeat because we're doing things wrong? And that all delivers the end-to-end value stream. Now, if you compare a value stream to, let's say, a hose in which you can push water, now the maximum capacity you have is the size of the hose, right? And all the stuff that you can push through it, that is the maximum capacity that the system can have in terms of the throughput. Now, what happens when we have a dent in the hose? Then we see that we are constrained. So that is a constraint in the flow that we have. And you can have multiple dents, but which dent has the most impact on the flow? That's the biggest dent. So what you need to do is you need to find the real constraint, what is really constraining your system, and then focus on that. So I get asked a lot, Marcel, can you come in and help us with test automation, for example? And then I come in and I see that the organizational part is a complete mess. The whole way they do, they say they do Scrum, but they are just doing vertical stand-ups, vertical meetings, right? That's a complete different thing. So they're constrained by many other things, and the only thing that I could do is I could add a little bit of value. I could shave off, let's say, 2 or 3 days of an entire release cadence of a quarter. Now, what makes more sense? So I go in and I say, well, based on my value stream analysis, this is where the problems are. I can, of course, make this a little fix, but it will, at the end, be marginal of what we're doing, and you do a lot of an investment there. So we need to look at what is the biggest constraint. And if we look at music store in corporate, what is the biggest problem they have where they start? That's the organization, so we need to start there. So first, we have a lack of flow. That's the first bottleneck, and we need to get rid of that. Now, this is traditionally how organizations are organized. So you see that we have a dev team, we have a test team, we have a QA team perhaps, we have people that do requirements, and then we have an operations team. And what happens if one of these cogs get delayed? Well, then the whole system is delayed, right? It's all intertwined. So what we need to do is we need to come up with a different organizational model. And that organizational model is, again, around those value streams, those customer journeys that you have. And each journey has a team on its own, which is multidisciplinary, meaning that that team will take care of everything that has to do with that value stream, and they can deliver that to production anytime they want. So if you've been in the previous session on events, for example, you can see how you can decouple these different systems and then tie them together as one complete system using events, for example. That's very common, event-driven architecture and microservices. But it's building those time-to-market optimized value streams that will then deliver. You see there's no interdependency between those teams, so every team can deliver the moment they want. It's just a matter of architecting your system in such a way that you can make this happen. And of course, this is something you do in a day, right? Now, this will take, of course, some time, some architectural work, but this is where you need to start. Then the second part is, okay, now we did some optimizations there. We are now able to deliver as a value stream. Now, what can we do if it comes to IT operations? Because there are many rules, there's a lot of governance going on. How can we optimize around this? And you need to ask yourself the question, are the old constraints still there? Do I need to really get a ticket to get a machine? And if I talk to a lot of companies where they say, well, we moved to the cloud. We now have our new ticketing system where you can request virtual machines that we will spin up on an auto provisioning system that is there, which is AWS, Azure, what else? I mean, so they still apply the old constraint on something new, which more or less gets rid of all the benefits that you have if it comes to a cloud platform. So remember, you want to release 30 times a day. So I do not want to shove tickets. I just want to provision a machine and then actually make use of that. I'm not going to buy new hardware. I'm just going to use software-defined compute. And I get new compute the moment I check in some code and push that to my cloud provider. So you move to the public cloud. You get a new, I would say, model if it comes to getting capital for your application. So it's capital expense versus operational expense. You only pay for what you use. And it gives us other flexibility to actually push that to the cloud. So it really, and I always say that DevOps and cloud are a match made in heaven because DevOps gets accelerated by the cloud and the cloud gets accelerated by DevOps. These two are really meant to be together, which really helps. So what I could do is I could take my MVC music store, which, let me show you here, it's just running on my machine. And this is the traditional application. I modified it a little bit, so it's now telling us that welcome NDC instead of welcome wherever I'm at this time. So hello NDC, you see it's a special version that we want to publish to the cloud now. So what we could do is we could say, okay, I understand this cloud thing. What I need to do is I just go to, for example, Azure. I create an app service there, NDC Minnesota, and let me publish to that particular location. So what I can do is go here, click publish. Then I want to create a new publishing profile. So let's see. Start. I'm going to create an app service, select an existing one, create a profile for that. Now it's searching for the resources. It finds my web app that I created. It's nothing special about the thing, and I click publish. And now what happens is it will package up my application. It will go out to the cloud, and it will push to that particular location. And now I'm in the cloud. That's how easy it is to actually get something in the cloud. I do not have to do any fancy things, no scripting, no all kinds of goofy stuff to get this going. It's just very, very easy to publish something to the cloud. It's as simple as this, and just I didn't spend enough money to get the performance here, but you just pay more and you get better performance. I mean, that's the great thing. If you write crappy code, it scales also very crappy in the cloud. I mean, the scaling model goes with the quality of the code that you really create. But you might say, what did you do here? Dude, seriously? We're here at NDC, we're a developers conference, and you are doing right-click publish? You should be banned from stage right away. Because friends don't let friends right-click deploy, right? I mean, Damien will be in the next session after me, and he tossed this sticker. You can get it even for your laptop if you want. But you do not do right-click publish, because that's like creating a new bottleneck and creating all kinds of problems. We want to centralize that, of course, create a build and other stuff. So our next bottleneck in this whole thing is, yes, I can go to the cloud and I can push it to the cloud very easily, but what I need to do, it's now still manual. I need to get the manual part out of here and just make sure that code that gets committed will just be pushed to the cloud. So what I need to do is I need to do CI/CD, create cloud deployments that way, and that is also not hard to do. If you would have asked me to do this 5 years ago, I need to go out and script a lot of stuff and do a lot of moves, you might say. But if you look at creating a build, it's just, I would say, almost too easy to be true, right? So if I go to a build, and I'm using Azure DevOps, by the way, but if I go here and say I would like to create a new build pipeline, the only thing I need to do is say, well, I'm still a classic guy, so I will use the classic editor at the moment. What is my Git repo? That's this one over here. I'm going to do a build which is nothing more than an ASP.NET web application. Since I'm on stage, what you normally then do is say, well, the tests, just remove those. You see what I'm doing here? I'm really doing best practices here. And now I say save and queue. And there I have my build. And it's now running on a hosted agent, which is in the cloud. I could also make a very simple adjustment here and say, well, use instead of this my local build agent that I'm running here, which is, I think it was the demo pool that I have. And if I save and queue that one, it will probably be faster done, because that is my agent running here. Okay? So if all's well, there you see the job is coming in, and it's now running on this machine. You can use the hosted versions of these agents. There are Visual Studio versions, 2017, 2019. You can run on Linux. You can run on some Ubuntu images. You can run on a Mac if you want. It's all there, and this is as easy as it gets to create a build. Now, creating a release is also very easy these days. So if I create a new release pipeline, what I can do is I can say, well, I would like to do an app service deployment, which is the type of application that I'm using. I'm applying this, say that this, I always go straight to production, right? So this is production. I will do one job and a task. I need to select my Azure subscription, which is a subscription that I've been using for the publishing from my desktop as well. Other than just waiting for the thing to load, is pretty fast to do. Then I have a web app on Windows, and I can select the web application, which is then NDC Minnesota. And now everything is set up here. So I do not have to do anything else. The only thing that I need to now manage is where is the artifact coming from. Now the artifact will be coming from the build that I have, and the build that I have is just the one that I just created. Okay, so that was the ASP.NET CI. Latest version, and I will call the location where I drop this stuff the drop location. I add this, I save this. If all is well, I already have a build now, by now, so I can create a release. It will then figure out that build number 2 was the one that is now available for me. I create this, and now I can follow along what it's doing. And it will use also a hosted pool of agents that is now pushing this to the cloud for me. And this is the way I can now very easily move this stuff in a complete CI/CD fashion. The only thing I can change to my release pipeline, by the way, is, go back one, when I edit this one, let me go to the release pipelines, releases, this is the new one, I'm going to edit it. What I can do is say here that the deployment trigger is continuously, so every time a new build is there, it will push it to the cloud. And I can do the same for the build. So if I look for the build here, and this is my standard CI that I just created, if I go edit here, I can set a trigger, and that will be a continuous integration. So every time I commit to the Git repo, I will get a build out of the box. Okay, and that's also very easy to just set up. So that's the way we just build pipelines, and this is the way we can get rid of all of this trouble. And this will not cost you like a consultant for a month or so to get this up and running. This is just following a video on YouTube, and you are off doing this. Okay, it's not complex anymore. You do not have to have a lot of complex software for this. So where are we? We now have value streams in teams. Every team is now able to push to the cloud very easily, so we can move much, much faster than we did in the past. So what will be next? And before we go to the next stage in optimizing this, I would like to ask you again to stand up for me, please. Because I need to take a second measurement. And the second measurement is all about, can we make more noise than we did in the previous ask that I did? Okay, so on the count of 3, we're going to make more noise. Okay, so 1, 2, 3. Thank you so much. Now, go back one question. Do the old constraints still apply? I just asked you to make more noise. I did not ask you to clap your hands. So please sit down. Because this is the thing that I wanted to show you, is that I can very easily program your mind to do exactly the same thing over and over and over again. That's our lizard brain. That's the way we operate. I programmed you to clap your hands to make noise. It's as simple as that. And now translate that into your work field. What you do every day, you come into the office. Do you ask yourself, do the old constraints still apply? Do I really need to scan my badge this time? I know it can be tiresome to always ask those questions with everything you do. But if you're trying to achieve different things and different goals, do the old constraints still apply? Be very careful about that and always ask yourself that question. Because things change. A lot of stuff that we've done for the past decades just does not apply anymore, and we need to come up with new things. So who knows, for example, where we came up with the notion of different environments? Who has a dev, a test, and acceptance in a production environment? Probably everybody. And where does it come from? Does anybody ask that question anymore? Because no, those are just the stages that we need to go through. But why? Well, the reason why is, in the past, it took like a long time to get a different environment. We needed to buy servers, we had people running around patching the cables. We need to have different configurations. It was very expensive to couple it with existing systems. So that was the reason we came up with the notion of environments. And this environment was then time shared with other teams, and we can then use and live that stuff for a while, and then people could do their testing, and then we could go to the next stage. But now I have this team that wants to deliver value to the market as fast as possible. What will happen if I would have environments that would be time shared between all those teams? That would be a big bottleneck again in my continuous delivering strategy there. So I need to come up with different things. So environments are okay-ish if it comes to the different stages of confidence that we would like to go to, but they're nothing more than a quality gate where we want to go to. The whole notion of needing an environment in terms of machines, needing an environment in terms of other setups in terms of security. Why not work with security from day one in such a way that you know that it will work in production? And this is where, for example, container technology can help you a lot in just building something that you can push through the different stages of, I would say, confidence, and then push that to production. So the next bottleneck for Music Store Incorporated is the testing. They have a lot of manual tests, and all those manual tests still take days to complete. So what is the next logical step that they will do to get rid of this bottleneck? Anyone? Automation, because that's what we've learned, right? We have learned to do automation as the problem-solving theory behind doing all these tests. But why not do it differently? Why can't we separate? So first of all, one of the things that we can do is we can say, well, we can create automation, but those automations are hard to maintain. They're very brittle to build. They break all the time when we make changes. They're often very flaky. I mean, I've used many, many different frameworks, and they're all flaky as hell. You just run your unit test or your UI test, and it runs perfectly. And then 2 seconds later, it doesn't run, and we try it again, and it runs again. And how confident am I? Well, you want to get rid of that. So I'm not saying that we need to get rid of test automation at all, but I do say that we need to be very careful to do the click and whirl, I would call, and that is, oh, manual goes to automated, and that's the way we solve the problem. There are different ways of solving the problem, and what we could do is we can then say, well, let's first think about a release. A release is we install software on a machine, and that exposes new features to the outside world, right? Now, those are two separate concerns that we have. We have the installation of bits, and we have the exposure of features. So why do we still do this in one step? Why don't we separate those out, build our software in such a way that the moment we deploy it, it does exactly the same as it did in the previous release? And now we move it to production, and still stuff is working as expected. And we have this technique called a feature toggle. We toggle the feature on, and now we are exposing the release. This would mean that I can deploy like multiple times a day without anybody being impacted, because it's constantly the exact same code base that goes to production with give and take a couple of feature toggles that I can turn on and off. And it gives me all kinds of new capabilities, and one of them is what we call testing in production. Now, probably most of you are testing in production and don't know it, but the idea is that we now have a formal way of doing this. And the formal way is that you build your features, you check them into version control, they get pushed to production, and they're behind feature toggles. And you can then do A/B testing, you can do dark launches, canary releases, all those kind of goofy stuff that we will go into in a couple of minutes. But this is like a prerequisite that you need to get in place. So start using feature toggles. And those feature toggles are not that hard. Who of you has ever programmed an if statement? Those that do not raise their hands, I do not believe you, or you're a manager. Okay? Because a feature toggle is nothing more than an if statement. It's just an if statement around some kind of a framework kind of thing, where you can then choose, when do I show the feature? Is that just a toggle and I show it to everybody? Is it a toggle and I show it to a cohort of users that I selected very nicely? What you could do is, for example, say, well, we have this notion of normal people, and we have gold members, and gold members get to see the new features. We don't tell them that they're the beta testers, but we just give them the gold card, right? They're happy to do it. You can do the same. I mean, Microsoft is doing this. They call those people that test their stuff as MVPs, right? And they're not a minimal viable product. They're a most valuable professional, by the way. That's very important to know. Who of you is a Windows insider? A couple of you, right? Well, you are their testers, right? They're testing in production, and you're their cohort of users that they selected. So that's the way this trick works, and everybody uses that. I'm not sure who is using WhatsApp here. WhatsApp, anybody? A couple of you. So WhatsApp had all of a sudden this feature with the blue check marks. Anybody remember those or still use them? So there was a whole thing going on the internet. I got blue check marks, and oh, I don't have blue check marks. How's that? And I want the blue check marks. And what happened there is that they were gradually selecting cohorts of users when they wanted to show the new feature and see how the things were handled by their system. Does it implement all of a sudden an overload on my systems? Is my system still stable when I try to release this feature? So this is the reason that feature toggles make a lot of sense if you're trying to do a 24/7 operation and want to publish new features all the time, but be in control of what's actually going on there. And the one and only thing that is really amazing about this is you can hand the feature toggle to your business. Because the business is now in charge of when to reveal the feature instead of you getting to spend your weekend in the data center installing the software. So feature toggles are really a great thing to do. Now, beware about feature toggles because they need to be maintained. Feature toggles in your code that live there for a long period of time become a technical debt. So if you look at feature toggles, then you have different types of feature toggles. For example, release toggles, those are the ones that I was just talking about. Those are the ones that you need to get rid of as soon as possible, as soon as something is always on. That means from that point on you want to remove the feature toggle, because otherwise your code will not be exercised with any unit tests as well, right? So if somebody would ever do something wrong with that if statement, then you have problems in production. Then you have operation toggles. Those are more the fail-safes for operation. When they have troubles, if it comes to performance, for example, they can turn off something. You get degraded performance of the system, of degraded capabilities, but your system still stays up and running. And then you have experimental toggles. Those are more on the right-hand side. So you see that they are changed with every request, perhaps. And you have permission toggles, and those will stay there forever because probably you don't want to make everybody admin of your system all the time, right? And those are also feature toggles. You just give people a user or they are admin, and that's a very simple way of doing feature toggling there. So where are we? We are using now the value streams. We're doing fully automated deployments. We have reduced our time to market into even minutes. So what's next here in the bottleneck? Well, the next bottleneck is our strategy if it comes to branching, because we are still using an old technique called, for example, Git flow. And if we're using Git flow, we're creating branches for the devs. The devs then create feature branches where they create new features. Then when that's done, they move it back to the development branch. Then gradually say, okay, now we're going to release. Then we create the release branch. Then we create some hot fixes, and that's actually then moved to master, which is then released to production. And this is a very standard way of delivering software. And I think that Git flow still is very, very helpful for companies that deliver libraries, that deliver, you might say, on-premise installations, because that makes sense that you want to harden stuff before you move it to production. But if you're running a 24/7 operations like Music Store Incorporate, then you might want to choose and say, no, I will always want to work based on master. And for this, we have GitHub Flow, where we just do a feature branch for something that we're doing. We guard the branch on top of that nobody can just commit stuff to there. We need to create what we call a pull request. That pull request is then elaborated on with your team, see if you've done the right stuff, fix some comments you might get from your colleague, and that's the moment that you even might run a build and a test release on that feature branch that you have. And if that's all okay, that's the moment you merge to master, and that's the moment it's released into production. Now the question you might ask yourself in the meanwhile is, okay, Marcel, great that we can now live and move this stuff to production right away, but what about compliancy? I need to be compliant with ISO whatever, I need to be compliant with COBIT whatever, I need to be SOX compliant, I need to be, well, compliant with everything that people come up with, right? And so how can we make this work? Well, one of the things that you need to note is when optimizing all of this stuff, you constantly need to ask yourself, does the old constraint still apply? So if I go into a company where they come, Marcel, we want to do this stuff, but we have this compliance framework that you need to adhere to. Say, okay, I can live with that, but I want to have a conversation first. What is the goal that we're trying to achieve with that compliance? What are the actual goals that we need to achieve? And if I go and look at COBIT, SOX, and all those different compliance frameworks, for software development and releasing of software, it comes down to more or less two principles. I need to have traceability end to end. Who came up with the idea? Who implemented that feature? And how did it get into production? And who approved that? I need to have at least, and that's the second thing, a 4 eyes principle in there, that I cannot think of something, build it, and put it in production, because then I would be the single point of failure of doing that, and I could then inject stuff that shouldn't be there. So if you have software that needs to be more restricted in terms of, it might be medical devices, it might be a nuclear power plant, or that kind of stuff. By the way, you'll be amazed what runs on a power plant, but I won't go there. The thing is that you might add additional eyes to the principle. So it's 4 eyes, 8 eyes principle, whatever. just more persons involved in approving this stuff. And what we can do is we can very easily achieve this goal with the first 4 I's that I want to have on my source code that makes a change. So what I could do, for example, I could go here to my repositories and to my branches. And what I could do is I can say, well, on the master branch, for example, I want to set a branch policy. And this branch policy now brings me to the fact that I protect this branch. I need at least a number of reviewers. And by the way, do not check this one, because then I'm not compliant anymore, because that now allows somebody that submitted the thing for pull request can also accept the pull request. So you do not want that, right? You want to have a switch in there. I can then say, okay, I also wanted to have linked work items, which is the Azure board story. You can also link Jira items to that, where you say, well, this was the story on which it was created, so you know the business owner that requested the feature. And I can then also say, I want to merge it based on fast forward scores. This is where your development team can say, this is the way we want to do mergers. You can enforce that even. And you can add build validation to that, so that the build must succeed in order for us to accept the review, for example. Okay, so that's a very easy way of creating a branch policy, and that will force me to always create a pull request before I can release to production. So where are we? We just created a better branching strategy, making it even faster to go into production. We can now release pretty fast, but what is the next problem that we will encounter? Well, every time I deploy, I have downtime. So can't we do that better? Well, yes, we can. For this, what we can do is we can use what we call blue-green deployments. Blue-green deployments are pretty easy to understand. The only thing you need is something like a load balancer between 2 sets of servers. And for this, what we do is we say, well, traffic comes in from the top, then we install software on a new node. All the traffic is still going to the old installation. Once I'm done with the installation, I'm then starting to move a little bit of the traffic to the new node and then see if the software holds. This is when the feature toggles are still off, because I want to see if it still works correctly. And if I get some confidence there, that's the moment I flip the toggle. Then I still look at if it's stable or not. And if it's stable, then we can go forward. And then gradually we move it up to finally 100%. After that, it's rinse and repeat. We just install the software on the other node, and then we go and move the traffic there. And that's a way we can very easily move between servers and get zero downtime deployment. Now, one very important thing here is this works great, but it only works great for software that is stateless. Meaning that if you are having a shopping basket, for example, and you keep that in memory, the moment you switch between nodes, of course, that data will be gone, okay? So be careful about that. Now, the way we can do that in Azure Web Apps is very easy. What I can do here is I can go to my web application over here. I can then say, okay, let's go to, let me look here. Oh, you can search, right? So I want to have slots. Deployment slots. And what is a deployment slot? A deployment slot is nothing more than creating more or less a copy of your already running servers. So now what I can do is I can say, okay, can you please create an additional slot for me? I just give it a name, which can be blue or green or whatever. I can either clone the settings or not. And the moment I do this, then I get a deployment slot where I can deploy my new software to. And then the other feature that's in there, you see it already here, the traffic is now 100%. If I have multiple deployment slots, I can say, can you please distribute the traffic like 10 to 90 or 80 to 20? And I can just give in arbitrary numbers there. And what they are doing is they're doing DNS round-robin load balancing for me. So any 1 out of 10 for 10% will get the other node. Now what happens is when they get to the other node, they get a sticky session cookie. So every time a request comes in, they know that it needs to go to that node. And that's the way I'm moving traffic gradually to the other node there. Now this is all nice and handy, but I want to do that in my automated pipeline, right? So I can create these deployment slots and do the deployment there. But for that, what I need to do is then go here to my pipelines, go here to my release pipeline, and here you see my new one that I just created with production on there. I could do an edit over here, I could then say, well, the job here, you can see that I can deploy to a slot. And then I can define the slot that I would like to deploy to. Now what I can do in a good release pipeline is say, well, just create one first. So I add normally one statement, create a deployment slot. That's when I start the deployment. And then I create multiple stages with moving the traffic to there. And I will show you that later in the final demo that I have, where I have this all added. So now we do blue-green deployments as another way of getting faster deployments 24/7 up. But there's still this one thing, and this is avoided, I think, in every conference talk, the database. Because this is the hard part, right? What if I make a schema change? And what I would like to do is I would like to give you what I would say a playbook which you can use, which you need to adjust for your specific schema change, but you can always run this particular playbook to get things done. So what is the playbook? Well, the first thing that you need to do, and this is also something that you're not used to, you're starting to create software binaries that are multi-schema compatible, meaning you understand the old schema and you understand the new schema, okay, whatever the change might be. And once you have that, then you deploy that binary to production. That means that now in production, I can handle both schemas all the time, okay? The next step that we need to do is then I'm going to update, so I pushed it to production, to support the schema. And then the next step is I'm going to update the tables and the table structure in such a way that the new code can go to the new schema. Now, there are a couple of caveats that you need to take into account here and be very careful about that. When you're using a SQL Server, for example, and you want to make, let's say, an additional column in a table, please do not always adhere to the naming conventions that, for example, they need to be in the middle because they're on alphabetical order. Because if you would do an in-between insert of a column, that would mean that all the pages of the data need to be rearranged and changed. So that change would invoke like a complete database problem. You would get your database back in a couple of minutes, depending on the number of data that you are mutating, but it's a very heavy operation. Instead of that, always append a new column to the end and make it a nullable column. Because when I execute that DDL statement, that means that it's a no-op for the database. It is just lightning fast, and I've done this on tables with millions of rows. It's just instantaneously. Now, what if I need to have a column that has a value? Well, then the second step is you start adding the default value to it, and that's the way you get then the column with the default value. Okay, so that's the way you need to take those steps. Now, the second thing that you need to be aware of is, okay, now I changed the schema. How am I going to move the data around? Because I have data in the old schema format, and now I need to have it in the new schema format. Now, there are multiple ways of approaching that, and it really depends on your setup. But what you can do is say, well, every time my code is run, I will do an update on both of the schemas, making the data replicate through the new schema and then let it sit there for a while. What you also could do is do a batch job in the background and start moving the data for you. Now, the latter is also important to be careful about because you do not want to create a denial of service attack on your own database, okay? Which sometimes happens if people are not careful. So when you move the data, it's a heavy operation. Make sure that you do it gradually. Do not try to do it instantaneously in terms of a move, and at least test this out multiple times before you actually do this in production. So finally now I am running on the new schema. The new data is in there. And what I then do is say, okay, now I'm going to update the binaries to only support the new schema. I deploy that to production, and then I clean the old schema. Now this is the playbook that you can run by, and this will work for every schema change that you make, but you need to really carefully engineer this to make this happen. This way, I can do a 24/7, no downtime update of my databases. Now this gives me now all of a sudden fully automated database updates, fully blue-green deployments. So I can now really be up 24/7, zero downtime. So what's next? Because we're not done yet, okay? The thing is that I would like to know how my system is doing. Remember that I'm using these feature toggles, and I really want to know what the performance is of my system. So the moment I deploy something, I want to see if the current state of the system and the new state of the system are similar in terms of memory footprint, in terms of CPU cycles that they're using, etc., etc. Okay, so that is important to understand. And for that, what we can do is we can use all kinds of metric systems. Okay, so we can inject metrics, and those metrics can come from different types of systems. So we can use New Relic, for example. We can use application insights. And those are the things that you get, which are very easy to implement, I must say. So let me show you how we can add telemetry to our system. And for this, what I will do is I will right-click on the music store here. And here you see the tab Application Insights. If you did not activate that, you can create here a notion of, okay, I want to inject application insights. What it will do is it will then go to, I can go here and then go to configure, configure application insights. You get to this page, and here you can then select where you want to send the telemetry. So for example, it will then look in your Azure subscription, and it can create an application insights resource for you. You see here that I can select then my subscriptions that I have. I think I have enough of those. And you see that I have NDC Music Store as an existing resource at the moment. I will not update it now, because what I would like to show you is the following. So when I run this, I have the telemetry injected. By the way, the only thing it will do is it will make an update to your web config, and it will add some assemblies to it so that it can intercept some of the calls that are there. And it will send then, per set of requests, it will send the data to Azure Application Insights. Now, when I go here and I go to Application Insights, I have the NDC Music Store over here, and I can go to the live metrics stream. And what you will see is that I will now have live telemetry. This was the local host instance that I'm running, and if I click here on certain items, you will see that the live metrics over here update. Okay, so you can now see how long it takes for a request to take place, how long it takes for dependency calls, and you can see the committed memory on my laptop. And you see, by the way, this is the other web server. That's the one that is running in Azure. That is also giving me the telemetry data. So you see that the web server there is only using 65 megabytes. And if I would go here and do some of these clicks, you will see the same effect. Okay. So you see here that the new requests are coming in. Now, what's very nice about this is that if I go to my homepage here, I can say go to the application dashboard. It will now generate a dashboard for me where I can see all the statistics about what is going on based on usage, based on reliability, responsiveness. I get all these beautiful charts and stuff, and I can, based on this, monitor what my system is doing. So very easy to add and something that is very useful. Especially if you look at the last step that I would like to do, if it comes to really automating everything. So where are we? We're fully automated. We have everything based on feature toggles. We know which features are used based on our telemetry that we have. And I can now do multiple releases a week still, because the problem that I'm running into is my final step is that I still have manual approvals, because this is because of compliancy, for example. Now, what I can do here is I can say, okay, what if for every stage that I go through, I could set up an approval? And that approval can either come from a person, or it can come from telemetry that I have. Now, this way, we can then approve this stuff to go to production only in the moment that we do not have, for example, problems in production. We have too high CPU, we have too many requests coming in, for example. That would be not the ideal moment to do a release, for example. And we can use all the telemetry then to be the gatekeeper of all of this. And you can add multiple of these gates as ingesting the telemetry data, and based on that, making decisions. Now, the way this works is that you go into this release phase where you saw the different stages that I have, and I will show you later in the final one how that works. And what you can do is then after every step that I'm taking, so for example, I do the blue deployment. Then I'm moving to, let's say, 10% traffic. That is the moment I can then add a quality gate there and say, okay, I only want to move to 30 or 40% if my CPU usage did not go up, if the number of requests errors that I have didn't all of a sudden go up, and those kind of things. And the moment all these gates pass, that is the moment the software gets released or gets moved to the next stage in that deployment pipeline. If there is not one moment that all three pass, then it will be rejected and it will never go into the next phase. And you can then do, for example, a cleanup where you say, well, I'm going to do a reinstall or a roll forward of my changes. By the way, the new way of doing things is not to roll back. Roll back is for chickens, okay? The new way of doing these things is roll forward. Because you can now deploy so fast to production, the only way to mitigate problems is to move along, roll forward. That's the moment you can mitigate the changes. So final result of all of this is then including those release gates that we have. Now let me go and show you how that looks in the final release pipeline that I have. Releases. And here you see the deploy to app services, and let me edit this, because then you can see what's going on. So here you see that I have my artifact coming in from a build. The first stage is then deployed to a staging environment. You see here that I create a staging slot. What I did, by the way, is I used variables. So I have an app service name, that is NDC Minnesota, which is the name of the web app that I'm using. You see NDC, that's the resource group that I'm using, and you see that I want to use staging as the name of the slot. I could have used blue, green, or whatever, the name that I love to use, okay? And in those tasks, I am then deploying to staging. I create the staging slot by nothing more than this command line, AZ web app deployment, and then create a slot, give it a name, and it will fix it for me. And then the next step is that I'm going to deploy here to that slot name that was the variable name that I'm using. So this way I'm then deploying to that particular location. So let me, just for giggles, do the MVC Music Store over here, and then views, and then shared, and then layout. And let me make a little change here. Edit with pipelines. I'm going to commit this. Commit it to master right away. I mean, I'm in God mode on stage, right? So that's correct. You see, by the way, that the build already kicked off here. So it's starting to do the build. I go to releases here. I was looking at this one over here. So after I did the first deployment, I could then either say here, I would like to wait a little bit for a certain next step, and that can be either I want to do a post-deployment approval by a person, so I could do something like freeze Marcel, and this is my alter ego right here. So I can use two sides of myself, the black side and the white side, you might say. And that's the way I can then approve a change that has been made. Okay? The other thing that I could do is I can set the gates over here. I can say, well, I did deploy to staging. Well, it doesn't really make sense now, but if I would go for 10% traffic, for example, then I can say, okay, I would like to add a quality gate here. And that can be any Azure function that I invoke. That can be Azure monitoring, for example. That can be the work items that I have on my Azure board. So, for example, you could push this stuff to production all the time and have this release gate wait on the final production stage until you're done with your sprint review, where the product owner moves the stuff to the done column. That's the moment these different things then get pushed to production, for example. Would be a nice way of doing that. And here you see Query Azure Monitor. This is where Application Insights lives. So I can then use my subscription here. I can use the resource group NDC, and you will see that I can then say, well, I am interested in, let me go here. Oh, sorry. Where did I go wrong? Resource group, filter type, this one. I want to do an alert rule, for example, and these alert rules are coming from Application Insights, which then can be anomaly, for example, in the number of errors that were there once I did a deployment. And that's the way you can automate all of these steps. Now here you see 10% traffic. The only thing what I did here is just one command, move 10% of the traffic to staging. And that will make the change there. So if I would go and have a look at the current releases that are running, releases. You see now this release is moving release 17. So if I go to the dashboard here and go to my app services, you now see that it's gradually rolling out on another deployment slot. So if I go to slot over here, I can now see that there are 2 stages, staging and production. You see 90-10. Okay, and that's the way it's moving the traffic now between those different nodes. So that's the way we've moved Music Store Incorporate to the new era with the new way of doing things. So that was the final result of the application. Now the final result of this session. Will you please stand up again? Because I hope you learned at least that old constraints do not apply anymore. And I would like to ask all of you, can you make as much noise as possible on the count of 3? 1, 2, 3. Thank you so much. My name is Marcel de Vries. I'm the CTO of Xpert. And thank you for attending my session. And I hope you have a wonderful NDC.